video, I'm going to talk about a special case of collisions. It's called the elastic collisions. So in your packet, we talk about elastic collisions, inelastic collisions, and perfectly inelastic collisions. You can look up the other two in your packet. Okay, look at the definitions. But now I'm going to talk about this special case. So the conditions for elastic collisions is the objects cannot stick together, momentum is conserved, and kinetic energy is conserved. So I have two objects that collide before the collision, and this is after the collision. So conservation of momentum tells me this. Okay. Now I'm going to do conservation of kinetic energy, meaning the total energy before the collision equals the total energy after the collision. This is a 1 prime m2 v2 prime squared. Now, in the second equation that I'm going to call 2, I'm going to get rid of the halves, and I'm going to put the terms that have m1 together to the left. So it should look like this. And at the same time, I'm going to factor out m1. So let's see if you can follow. I was told you are good at math, so I can do multiple steps at once. Okay. Then I see that I can do the difference of squares here. v1 plus v1 prime m2. Okay, this is all algebra. There is no physics here. It's all algebra at this point. No? So I'm going to take this equation. I'm going to do the same thing. I'm going to put the terms that have the m1s together. I forgot to put the primes here. Okay, so m1 v1 minus v1 prime equals m2 v2 prime minus v2. Now I can see that I have this term on the left, I have it right here, and the term on the right, I have it right there. So I can pretty much cross this out. So what's left? v1 plus v1 prime equals v2 prime plus v2. So I'm going to put the terms before the collision together and the terms after the collision together. Or it can, sometimes you see it written like this, negative. So that there is an order, so we put the object 1 before object 2. Now this is powerful, and it's only true if you're doing problems in one dimension. Okay? All right. Just wanted to make sure we're recording. This means that the relative speeds before and of the two objects before and after the collision are equal, right? So now this equation, I think we can just write it v1 minus v2 equals v2 prime minus v1 prime. Okay, this is prime here. All right. So I'm going to leave that there, and I'm going to do an example. So now you just memorize that, unless if you want to do the proof, which I don't think you want to do. So the example I have is an object that has a mass of 3 kilograms, another object that has a mass of 4 kilograms, facing each other. This one is going at 4 meters per second. This one is going at 3 meters per second. They're going to collide, and I want to find the velocities of the two after the collision. So let's start with conservation of momentum, and I'm going to use this to help. Actually, let's start with this. So v1 minus v2 equals v2 prime minus v1 prime. If you just memorize that, you don't have to derive it every time. So it's 3 minus negative 4, because this is going in the negative direction, equals v2 prime minus v1 prime. 7 equals v2 prime minus v1 prime. So I'm going to call this equation 1. Now let's write the conservation of momentum. Okay, now let's put in some numbers. So this is a 9, that's a 16 in the negative direction, equals 3 v1 prime plus 4 v2 prime. So this is negative 7 equals 3 v1 prime plus 4 v2 prime. is another equation that I'll call 2. Now I'm going to take these two equations and I'm going to rearrange this so that there is some order. I'm going to write it as negative v1 prime plus v2 prime. Yeah. All right. So I'm going to take equation 1. I'm going to multiply it by 3. Basically, I have two equations, two unknowns. That's something that you should be able to do easily. So if I multiply that, this is what I'm going to end up with. 21 equals negative 3v1 prime plus 3v2 prime. And I'm rewrite equation 2. I'm going after the v1 prime, basically. So if I add, I get positive 14 equals 7v2 prime, which makes v2 prime equals 2 meters per second positive. Okay. Now to find v1 prime, all I have to do is plug it into equation 1. So I get 7 equals 2 minus v1 prime. v1 prime equals negative 5 meters per second. Okay, thank you.